Hello guys, welcome back to my YouTube channel. Our today's subject is about digital design and computer organization, and we shall briefly discuss upon the topic addressing modes. So what are addressing modes? Addressing modes are a crucial aspect of a computer architecture and assembly language programming, influencing how instructions specify the location of operands. These modes determine how a processor accesses data from memory or the register to perform operations. Understanding addressing modes is essential for efficient programming and optimizing resource utilization. Addressing modes plays a vital role in shaping the design and functionality of the processors. It provides flexibility for the programmers to implement diverse and efficient algorithms in software. Types of addressing modes: register addressing, direct addressing, immediate addressing, indirect addressing, index addressing, relative addressing, auto increment addressing, and auto decrement addressing. To begin with, register addressing mode. It is a type of addressing mode in a computer architecture where the operand is directly specified by a register. In this mode, the instruction refers to the content of a register and the operation is performed on the data stored in that register. This mode is particularly efficient because it avoids memory access and directly utilizes the high-speed registers within the CPU. Let us have a look on this example where move A, B, where it moves the content of the register B to register A. Here it is the pictorial representation of register addressing mode. The next addressing mode is direct addressing mode. It is a type of addressing mode in a computer architecture where the operand is specified by a constant value or memory address directly in the instruction. In this mode, the effective address of the operand is provided within the instruction itself. For example, move A, 2000, where it moves the content of a memory location 2000 to register A. Immediate addressing mode. In immediate addressing mode, the computer architecture where the operand is a constant value that is directly specified within the instruction itself. In this mode, the data to be operated on it is a part of the instruction itself, rather than being stored in a memory location or a register. For example, move A, hash 5, where move the immediate value 5 to the register A. And here we use opcode and operand for immediate addressing mode. Indirect addressing mode. It is a type of addressing mode in computer architecture where the operand's address is not specified directly in the instruction, but instead it is held in a register or the memory location. The actual operand is located at the memory address or in the register that holds the effective address. Here, the effective address holds the actual memory address of an operand. There are two types of indirect addressing mode. The one is indirect addressing through general purpose register. Here, let us have a look on the example add A, R2, where it adds the content of a memory location specified by the value in the general purpose register R2 to register A. Here, let us have a look on the pictorial representation where the register R is first connected to the effective address which is present in the register set, and then the effective address is connected to the operand which is present in the memory. The next is indirect addressing through memory location. Here the effective address and the operand both are present in the memory block itself. The next is index addressing mode. In index addressing mode, it is a type of addressing mode in computer architecture where the operand's address is determined by adding a constant offset which is index to the contents of a register. This mode is particularly useful for accessing elements in arrays or data structures, where the base address is stored in the register and the index specifies the displacement or the offset from the base class. Here in the picture, we can see that index register is connected to the register set and the register A is also connected to a offset, and both the register set and the register is connected to the operand. There are two types in index addressing mode. One is offset is given as a constant, or offset is it is in the register index register. Relative addressing mode. Relative addressing mode is a type of addressing mode in computer architecture where the operand's address is determined by adding a constant offset to the current value of the program counter or instruction pointer. This mode is often used for specifying the target address of a branch or jump instructions, allowing for conditional or unconditional transfers of control within a program. Here we could see that the register A and the program counter is connected to a constant offset, and that constant offset is connected to the operand of the memory. Here example is jump of 100, where it will jump to the instruction of the address PC, that is the program counter, plus 100. Auto increment addressing mode. Here the operand's address is automatically incremented after each access. This mode is commonly used when accessing elements in sequential memory locations such as arrays or lists. The auto increment feature simplifies the process of accessing consecutive memory locations. Here in the picture we could see that 5C is allocated with the memory allocation 3298 and 6B with 3300. Here the difference is 2 bits. So when it goes to the next bit, which is 7F, and it is incremented by 3302, incremented by 2 bits. Auto decrement addressing modes. Here the operand's address is automatically decremented after each access, similarly to the auto increment addressing mode. Here it is often used when accessing elements in sequential memory locations such as arrays or stacks. Here we could see in the program where 6C, that is 3302, here is a memory location, and for 1F it is again decremented by 2 bits. So let us have a look on difference between Boolean algebra and general algebra. So Boolean algebra deals with the binary values which can take only two values, which is typically either 0 or 1. Whereas general algebra, it is also known as abstract algebra. It is a broad field and that can have various algebraic structures such as groups, rings, fields and vector spaces. The basic operations in Boolean algebra are AND, OR and NOT, and these operations are often represented by the following symbols. Whereas the general algebra, it deals with the variables that can have multiple values and considers various algebraic structures with specific operations defined on them. For example, it has operations like multiplication, addition or composition. Boolean algebra is widely used in digital logic design and computer science. It helps in designing and analyzing circuits that operate with binary signals, where the variables represent true or false, on or off conditions. Whereas in general algebra, we find applications in diverse areas, including mathematics, physics, computer science, and cryptography. It provides a framework for studying and understanding algebraic structures and their properties. Thank you guys. Stay tuned for more such videos. Please do like, share, and subscribe.